In this video, I will guide you through a problem in Smith's Organic Chemistry. I'm Stoddard, founder of Study Chem, the place for students to turn for higher grades in OChem. Let's get started. Question 19 here is asking us, what is the major product form when each alcohol is treated with hydrochloric acid, HCl here? So I highly recommend working through the mechanism to figure out what the carbocation is and if there's rearrangement or not. Here's the hydroxyl group. Let's identify what carbon it's attached to. This carbon here is tertiary, so it's a tertiary alcohol, which means that this reaction occurs by SN1. So let's think about what the carbocation intermediate is going to look like. The carbocation intermediate is going to have this same six-membered ring, these two methyl groups coming off, and the carbocation is going to be right here. Okay. Now we want to think about if this carbocation can rearrange. A tertiary carbocation is the best. This carbocation cannot rearrange to give anything more stable than a tertiary carbocation in this particular example. So chloride is just going to attack this carbocation, and after reaction we're going to get our same molecule here with a chlorine taking the place of the hydroxyl group. Okay, so let's continue thinking along these lines. So let's take a look at this alcohol here. Here's the hydroxyl group. It's attached to this carbon here, and this carbon is a secondary carbocation. Secondary alcohols react by SN1. They give carbocations. Let's draw the carbocation intermediate and think about its stability and whether it can rearrange. Okay, so we have the secondary carbocation. Next door to it, we have a tertiary carbon. So in this situation, a methyl group can migrate over. So these two bonding electrons here, along with the whole methyl group, can migrate over to here, and that gives a new carbocation intermediate. And I'll just use blue here to highlight the CH3 group that has moved. There's of course a bunch of methyls in this molecule, but the carbocation now is going to reside at this center on the left. Okay, so let's put a plus there and circle it. Now the chloride is going to attack this tertiary carbocation. Okay, so the easiest way to identify whether there's going to be a carbocation rearrangement or not is once again think through the mechanism. Draw the carbocation. Here you can see how it's a secondary carbocation. Next to it is a quaternary carbon. If we move one of those methyl groups over, we're going to have a tertiary carbocation. Tertiary carbocations are more stable than secondary carbocations, so it's going to give us, after reaction, the major product with a halogen, in this case chlorine, taking the place of the alcohol, but way over here on this carbon. So let's draw the product that would result. Let's draw chlorine here. Okay. Let's do the same kind of process down here. Let's identify the hydroxyl group. It's attached to this carbon. It's a secondary center. Okay. So that means it's going to react by SN1. That means they're going to be carbocation intermediates. Let's draw the carbocation intermediate and think about whether it can rearrange to form a more stable carbocation. So here's a secondary carbocation. What you want to notice is that adjacent is a tertiary carbon. This tertiary carbon can, in a way, donate its hydride. So here's a hydrogen with two bonding pairs of electrons. So let's go ahead and migrate over that group. And we get a new carbocation that's now tertiary. So the positive charge now is up here. There's a hydrogen that's moved. I won't clutter this drawing by drawing it, but here's a tertiary carbocation which is more stable. So rearrangement has occurred here. Now if we continue thinking through what the product is, we want to take chloride and attack that carbocation. So that's going to give us the major product here with a chlorine at the tertiary carbon. Okay? Thanks for watching. Think through the mechanism, and hopefully you can figure out when rearrangements occur